In this video, we are going to take the regression equation from the previous video, in which we predicted the expected film revenues using the film's budget and the year of release. And we are going to calculate first the fitted values for the revenue given a set of explanatory variables, as well as incremental values. So how much is revenue expected to change for a given change in one or both the explanatory variables. First, let's see how to calculate the fitted values, also called predicted values. You can see here the regression equation where we've put in the estimated coefficient for the intercept, the estimated coefficient for the slope corresponding to the year, and the estimated coefficient for the slope corresponding to the budget. The first question is going to be, what is the expected revenue for a film released in 1992 without a budget? Here, the answer should be easy. A film without a budget is unrealistic and outside the range of our data. We cannot extrapolate. Indeed, it's not possible to make a movie without having some budget. So it will be meaningless to try to extrapolate the revenue. Your answer should be the same if I asked you, what is the expected revenue for a film released in the year 500? There was no movies back then, so it would be meaningless to try to predict a revenue. Now let's see a more realistic case. What is the expected revenue for a movie produced in 1970 with a $10 million budget? So we just take our regression equation, we replace the year by 1970, and we replace the budget by 10 million. Then we take our favorite software, whether it's Excel, R, or a scientific calculator, and we find that the result is approximately 242 millions. Now let's talk about calculating incremental values. We have the same regression equation with the same estimated coefficients, and we are going to ask first, what is the expected drop in revenues associated with delaying a film's release for 1 year, all else held constant? This last part, all else held constant, means that the budget is not changing. In that case, it's very easy. Only one thing is changing, it's the year. And so we take the coefficient for the year, minus 5 millions, roughly, times 1 year, and we get minus 5 million. Be careful here. Don't forget the minus. The slope coefficient is not just 5 million, it's minus 5 million. We can also ask, what is the expected difference in revenues for a film released in 1990 versus one listed in 1980, all else held constant, so not changing the budget again. In that case, only the year is changing again, and so we take the slope coefficient for the year, minus 5 million, times the difference between the two decades, so 1990 minus 1980, and we find that the expected difference is roughly minus 58 millions. Finally, what if both the year and the budgets are different? What is the expected change in revenues associated with a film that is delayed by a year, but also given an additional $10 million of budget? Now we have to look at both the coefficient for the year and the coefficient for the budget. Again, we put these 1 year difference and 10 million difference in the equation, and we find that the expected change is approximately 24 millions.